Japan built a wall you can see from orbit, 400 kilometres of concrete along its own coastline, $12 billion, taller than a 4-story building, and almost nobody outside Japan knows it exists. But here is what makes this thing strange. 2 towns on that same coast, 40 kilometres apart. One wave hits both. The first town had spent 24 years building its own seawall, 10 meters tall, 2.5 kilometers long. They called it the Great Wall, and they were proud of it. That morning, 140 people died there. 41 were never found. The wave tore 500 meters of that wall out of the ground. The second town had no wall. It had one gate, pushed through by a mayor everybody called a madman. That morning, the second town lost nobody. Not one person. Same wave, same coast, 0 dead. The difference was 5.5 meters of concrete. That is why this wall exists. And there is one more thing, which is the part engineers argue about at conferences. If this wall ever fails, it may kill more people than no wall at all. Now watch what they actually built. Quick thing first. If you like engineering that nobody explains properly, hit subscribe. It genuinely helps us keep making these, and there is a lot more coming. Right, back to the coast. 11th of March, 2011, 2:46 in the afternoon. A slab of the Pacific Plate slips under Japan, magnitude 9.0. The main island physically moves 2.4 meters east. The seafloor lifts. 500 billion tons of water get pushed upward. The earthquake kills almost nobody. Japanese buildings hold. What kills people arrives 20 minutes later. Not a breaking wave. Something worse. The sea level rises, and it does not stop rising. Water keeps coming for 8 minutes without a pause, carrying cars, houses, fuel tanks, and eventually entire burning buildings, 10 kilometers inland. At Miyako, the water reached 40.5 meters above sea level, 40 meters, a 12-story building. 19,759 people died. 2,500 more were never found. And here is the number that broke Japanese engineering. Almost every one of those towns already had sea defenses. They had spent decades on them. Almost none of them held. Which brings us back to that first town, Taro. Taro has the worst luck in Japanese history. Wiped out in 1896. Wiped out again in 1933. So in 1934, the town started building. Not the government, the town itself. 24 years of work. 10 meters tall, built in an X shape so a wave from any direction hits concrete. 44 marked evacuation routes up the hillside with solar panels so the lights would still work when the power died. Taro was not careless. Taro was the most prepared town on that entire coastline. Foreign engineers came to study it. The wave that arrived at Taro was 16 meters. The wall was 10, and here is the detail that matters. The wall did not break from the front. Water went over the top, filled the town, and then on the way back out, it scoured the ground from behind the wall until the foundation simply was not there anymore. That is the engineering problem, not the wave arriving, the wave leaving. Now the second town, Fudai. 3,000 people in a cove between 2 mountains. In 1945, it got a mayor called Tohoku Wamura. Wamura had watched the 1933 tsunami with his own eyes. It killed 137 people in his village, so he demanded a floodgate across the river valley, 15.5 meters tall. The prefecture told him the height was absurd. His own villagers told him it was money burned. The standard insult was that Wamura had lost his mind. He was mayor for 42 years, and he spent most of them forcing this one project through. Then he retired. Then he died. And for decades, the main thing anyone knew about Tohoku Wamura was that he had built the most expensive, useless concrete in the prefecture. The wave that reached Fudai was around 20 meters. Some water came over the top. You can still see the mark on the towers. The gate held 3,000 people. Nobody died. Afterwards, villagers went to his grave to say thank you. One mayor, one wall, 3,000 people alive. That village gave Japan its blueprint. Build it taller. Build it everywhere. Quick one, because opinion on this is genuinely split. If you lived in one of these towns, would you want the wall? Tell me in the comments. I read them. So how do you build a wall against an entire ocean? Start with the brutal truth. Nobody in Japan believes this thing stops another 40 metro wave. Nothing stops that. Its actual job is to buy a town enough minutes to get up the hill. And most of it you will never see. Only about 14 meters shows above ground. The rest is buried. Long before any concrete appears, survey ships spend months drilling holes along the entire route. Every section of coast is sitting on something different. 3 foundation types: soft clay, dense sand, hard rock. Each one needs completely different engineering underneath. Then the first job, which nobody expects: demolish what is already there. Every failed wall gets studied, then torn out, then replaced bigger. 440 contractor teams, all working at once. One of them going bust halfway leaves a hole in the line. And a hole in a tsunami barrier is not a hole. It is a funnel. The tide gives crews about 4 hours a day on the seabed. Every minute is counted. In the clay zones, the ground will not even hold a bulldozer. Huge steel plates get laid down to spread the weight, and the machine ends up riding on top of the mud rather than sinking into it. The foundation goes in 25 meters under the surface, inside the breaking surf, in the water that had flattened this coastline a few months earlier. Divers guide 5-tonne boulders into position by hand, underwater, where they cannot see the whole structure. Engineers check the work by sonar and have to trust the data completely. Between the boulders and the fill goes a filter layer. Miss it, and the wall quietly bleeds itself away from the inside over 20 years. Then a geotextile membrane, which stops fine soil migrating into the rubble. It works silently, forever, and if it tears, nobody finds out until it is far too late. Weeks go by with nothing visible at all. Then the stone mound finally comes up out of the water. Now the real wall begins. Steel piles go 10 meters down into the seabed, and their only job is protecting the base of the wall. The edges lock into each other, so load passes from one pile to the next, and the whole row acts like a single object. And that steel is not there for the arriving wave. It is there for the retreating one. Backwash is what pulls foundation sand out. Backwash is what killed Taro. One buried boulder can deflect a 12-meter pile sideways and destroy the entire alignment. So they find it first, drill it, crush it, and drive the pile through the cleared hole. Then the fill. 30 dump trucks on 16-hour shifts. 300 millimeters at a time. Never more. Go thicker and the roller simply never reaches the bottom of what it is standing on. 98% density. Measured on every layer. Miss it and the inspector stops the site that day. Inside the body of the wall sit reinforcement layers, like rebar, but for compacted earth. And in the middle, a clay core, which is the wall's internal waterproofing. One night of heavy rain can slump 600 millimeters of slope and send an entire section back to the start. So the slope gets covered before every rain, always. At 10 meters, the concrete panels arrive. 7 tons each, 37 different shapes, because the coast curves and the wall cannot. The mix is designed to flow around every steel bar on its own with no vibrating, so the front face comes out flawless. That face has to survive water moving at 30 kilometers an hour and keep doing it for a century. They test each panel by tapping it. A solid ring means good concrete. A hollow sound means the panel gets crushed, even though it is finished, even though it is paid for. Then the crown wall on top, angled 10 degrees from vertical, with a curved lip that throws overtopping water back out to sea instead of down into the town. In front of everything, tetrapods. 32 tons each. They are not placed precisely. They are dropped, and they find their own stable position. Chaos producing order. The gaps between them are not a flaw. The gaps are the mechanism. Water flows through, energy dissipates, and the wave exhausts itself before it ever reaches concrete. Then the hardest part of the whole project, the holes. 443 gaps in the wall for rivers, roads, and harbors. Every one of them needs a gate. Every gate is a potential death trap. 70 seconds from alarm to sealed. That is the entire window. No human decides. A seismic sensor triggers closure the moment the ground starts shaking. Some are 22-metre steel curtains held open at the top, so if the power fails, gravity still closes them. 443 gates, 1 control room, 4 minutes and 20 seconds to seal the entire coast. Japan drills it every 11th of March. Where the coast turns to cliff, there is no beach to build on, so the wall gets anchored straight into the stone. Bolts driven 2 meters into basalt, then concrete fired on at 100 kilometers an hour, which grips far better than pouring ever would. The cliff itself becomes the barrier. And offshore, submerged breakwaters trip the wave 200 meters out before it reaches the coast. One of those units is a 60,000-ton floating box that has to be sunk to a depth of 63 meters and land within centimeters in 30-knot winds. So does it work? In 2022, a magnitude 7.4 earthquake hit the same coast. All 443 gates closed. 0 cracks, 0 shifted tetrapods. Total settlement across 400 kilometers in 2 years, 14 millimeters. That is exceptional. But that was an earthquake, not a tsunami. And the objections are serious. A wall that gets overtopped lets water in gradually. A wall that actually breaks releases everything at once, like a dam giving way. That is the argument you heard at the start. Walls also make people feel safe, and feeling safe stops people evacuating. The wall is supposed to buy time. It was never supposed to replace running. The fishermen lost too. You cannot read the sea, you cannot see. Several fishing cooperatives fought the wall in their own bays and lost. And in a lot of these towns, the survivors were relocated up the hillside anyway. So in places, the wall now stands 12 meters tall, protecting empty ground, while the people it was built for lie 400 meters up the hill and cannot see the ocean their families fished for 200 years. Not everyone accepted it. Kesennuma fought for lower walls combined with raised ground and evacuation routes. What they kept saying was that they wanted to live with the sea, not behind it. And they won some of it. The project is around 80% complete. And the honest answer is that nobody finds out whether it worked for another 50 or 100 years, because that is the trap. Taro's wall looked like a success for 77 years. Right up until the afternoon, it was not. The real lesson is smaller than 400 kilometers of concrete. Taro built for the wave that people remembered. Wamura built for the wave that was worse than anything he had ever seen. One of them was called a model. The other was called a madman for 40 years. Tell me in the comments which one you would have voted for at the village meeting in 1960 with no idea what was coming.